We're going to do a quick tutorial on electron configuration. One of the things that I want you to do for this assignment that we talked about in the past is that I want you to go ahead and number your representative groups on your periodic table that was given to you last 9 weeks. So if you notice, I have that on mine. Column 1 is going to be group 1, and we know that's already group 1. This is group 2. The transitions, we kind of skip over them as not being representative groups. Nonetheless, when you do number them, they go 1 through 18. But for these purposes, we're going to go ahead and just leave those to the side. So then we go on to group 3, group 4, group 5, 6, 7, and 8. Okay, so those are your 8 representative groups that we need for your electron configuration and the assignment for today. If you recall from yesterday, we went ahead and we wrote down the sequence based on the off-ball diagram. And so here's part of the sequence. I didn't put all of it. We're not going to even use all of it today. But at least have that handy in your notes. Remember, refer to page 35A and 35B for today's assignment in order to get that done. For the first part of your assignment, it's asking you to identify the group number, total number of electrons, number of valence electrons, and electron configuration. So we're going to go ahead and do the example for, we'll just say magnesium. Okay, it's in the middle portion of your assignment, so that's going to be our example. As far as a group number, if we look up magnesium, magnesium is element 12. There it is. It's going to be in group 2. So we're going to go ahead and write down 2. Okay, as far as the total number of electrons, going back, remember that the acronym APE, APE, is atomic number. Protons and electrons happen to be the same number. Magnesium is atomic number 12, so that means that it's 12 electrons as well. Before we write the number of valence electrons, I'm going to go ahead and do the electron configuration first. And for that, you're going to have to use your sequence from yesterday. So starting with the beginning of the sequence, as we discussed yesterday, it's going to be 1s2. And then going on to the next one, because 2 electrons is not enough, we need to have all the way up to 12. It's going to be 2s2. After 2s2, it's 2p6. After 2p6, let's see, so far we have 10. So we need 2 more to make 12. So the next one is conveniently 3s2. Okay, so it's asking us to give the number of valence electrons. When you're reading it from the configuration, just look at the larger numbers, the 1, the 2, the 3, and pick the one that's the largest. In this case, between the 1, 2, and 3, it's 3. And then identify how many electrons are in that energy level. So in this case, it's going to be 2. So the number of valence electrons for this one would be 2. The other thing that you can do is you look at the group number. So because magnesium is in group 2, that would also tell you that it has 2 valence electrons. So the group numbers also identify the valence electrons for that particular atom. If we were talking about aluminum, aluminum has 3 valence electrons. If we're talking about phosphorus, phosphorus has 5 valence electrons, and so on. Okay, as we move on to the next portion of the assignment, it says write the name of the element, number of valence electrons, and group number. Okay, in this case, to do that, you're doing the reverse. You're just counting the number of electrons that are available in the configuration. So in this case, we have 2 plus 2, making that 4, plus 1, making it 5. So you go on to your periodic table, you look for element 5. Okay, in this case, it's boron. So what you're going to do is go ahead and write down that the element is boron. Okay, as far as the valence electrons, I can do it two ways. I can either look at the largest number that I have on the configuration. In this case, it's a total of 3 electrons. 2 plus 1 gives me 3. So I can simply say that it's 3 valence electrons. I can also look at the group number and know that it's going to be 3 valence electrons, which, by the way, it's also asking me for the group number. And I will write that it's 3. Okay, so that's pretty much what you do for this assignment. And based on your information that you have on this, you're going to go ahead and answer the questions that are here for 18 through 21.